When a major crime happens today, it leaves behind a massive digital exhaust. Every phone call, security camera, and transaction creates a record. But an investigator working linearly, watching video minute by minute, reading reports page by page, is mathematically incapable of processing terabytes of this data. A standard 48-hour investigative window simply doesn't contain enough minutes for a human to watch 50,000 hours of footage. This creates what experts call the information overload pipeline. Crucial evidence piles up much faster than human eyes can review it, causing investigations to stall while data sits idle in an evidence locker. Solving this requires a shift from human deduction to algorithmic parallel processing. Instead of one human looking at a single piece of evidence at a time, we built systems designed to read, watch, and listen to thousands of files simultaneously. Investigators now face a paradox. The more data they collect, the harder it becomes to find the specific truth buried inside it. To process that much raw data, investigators start with the written word. They deploy natural language processing, or NLP, across massive, messy archives of police reports, financial logs, and witness statements. This shows how NLP handles unstructured text, paragraphs without a strict format. The algorithm scans decades of messy text in milliseconds. It filters noise and pulls out behavioral patterns, collapsing down millions of words into an isolated list of names, dates, and locations. Once the text is filtered, investigators turn to the second pillar, computer vision, applied to the endless, overwhelming feed of CCTV cameras. Look at this chaotic intersection. A human reviewer will eventually blink, lose focus, or simply get exhausted watching a screen this busy. Computer vision algorithms hold a severe operational advantage. They can relentlessly track a specific physical anomaly, like a red jacket or an out-of-state license plate, across thousands of hours of video without ever feeling fatigue. The third pillar brings in the intercepted phone calls, radio chatter, and recorded communications. Here, audio algorithms map out voice biometrics. They measure pitch, tone, and vocal cadence to match specific phonetic patterns across thousands of different audio files at the exact same time. NLP, computer vision, and audio analysis are highly effective filters, but if investigators run them in isolated silos, leaving the data separated, they still have severe blind spots in their case. To actually solve a complex case, these isolated data streams have to converge into a process called cross-evidence analysis. Imagine a scenario with three distinct variables: a flagged phrase spoken on a tapped phone call, a partial vehicle match caught on a traffic camera, and a specific address noted in an archived text report. Manually cross-referencing these separated audio, video, and text clusters takes months, but AI runs the matrix simultaneously, instantly identifying the correlation where the tap, plate, and address intersect. Expanding into a bell curve, the model isolates the extreme edge, mathematically confirming a direct lead. This synthesis identifies probable cause in a fraction of the time, allowing a detective to move toward a search warrant while the trail is still fresh. The true utility of investigative AI lies in this specific synthesis, identifying the overlap between events that would otherwise appear entirely unrelated. The ultimate consequence of this massive computational speed is a drastically compressed investigation window. When you shrink the timeline between a crime occurring and an arrest warrant being issued, you mathematically reduce a perpetrator's probability of escape. They simply don't have the hours required to flee a jurisdiction or destroy physical evidence. But the machine cannot operate in a vacuum. A human detective still has to apply their intuition to direct the initial query and define the parameters. The algorithm only executes the vast search. Computational power scales a detective's deductive reasoning, allowing a single investigator to oversee an analysis that previously required a citywide task force. Sherlock Holmes still has a job. He just needs a GPU to do it. If an algorithm can flawlessly synthesize an infinite amount of digital evidence in seconds, it raises a crucial question for the future. Are we entering an era where committing the mathematically perfect crime is impossible?